today? Are you okay? I really hope so. Today we are going to talk about the Poisson distribution. Okay, we are going to explore some math to calculate the probability of one event based on the average of that event. Okay, in that case of the Poisson distribution, the average represents the lambda, and the probability you want to find out it represent the x. So let's talk about the murders. Okay, let's say on your country you have the average of 5 murders per month. Okay, and it does represent the lambda. In that case, it's the Euler up to minus lambda, and you would like to find out the probability to happens more than 2 murders per month. Okay, that's the algorithm we are going to explore about the Poisson distribution. The probability it's to happen more than 2 murders per month. Okay, the month, the probability it represent the x. So we can say we are trying to find out the probability of the x it's happened more than 2 times. Okay, when we are working with the more, we can say the equation it's like the 1 minus the probability multiplying the x minus equal to, we got to insert the number 2 of the probability. So how gonna be the equation of in that case? Let's create it. It's the probability of the murder be more than 2 per month. So it's equal 1 minus the probability of the murder be minus or equal to. We can isolate the probability, so it's gonna be 1 minus, and we need to insert all the event of the probability. It's the probability of the murder be 0, 1 and 2. So let's create the probability of the event it's equal 0 more the probability of the event it's equal 1, and the probability the event it's equal 2. We need to sum all the probability 1 minus the events, and what is the probability? It's just here, it's the Poisson distribution. So it's the 1 minus the probability, the Euler up to the minus lambda. Lambda represents the 5 murder, it's the average, multiplying the 5 up to the x, in that case it's the 0 divided by 0 factorial more Euler to the power of 5 multiplying the 5 to the power of 1 divided by 1 factorial more Euler to the power of the 5 multiplying the 2, no, multiplying the 5 to the power of 2 divided by 2 factorial. You see, we have the Euler to the power of minus 5 equal on the 3 equation, so we can isolate it let's type here, it's 1 minus the Euler to the power of the minus 5 multiplying 0 factorial divided by 0 factorial, it's 1 more 5 up to the 1 divided by 1, it's the 5, and 5 to the power of 2 divided by 2, it's the 25 divided by 2, it's 12, 5. If we sum this expression, we have 18, 5 multiplying the Euler to the power of minus 5, 1 minus Euler. With the calculator we can use the expression of the Euler to the power of minus 5 multiplying 18, 5 minus 1. It represents 87.53%. That's the chance, the probability to happen more than 2 murders per month. 87.53% to happens more than 2 murders based on the average of 5 murders per month. Okay, that's too high. That is not a place to visit at all. Better stay at home. So now we are going to bring it to the algorithm. We are going to explore this equation, the Poisson distribution, with the Python. Okay, so let's create the algorithm, the poisson.py. We're gonna import math, just that. Let's create the function Poisson, and we're gonna pass two values, the lambda and the probability value. So in that case, let's call it the average, and the key, or the x, let's call it x like we did before. Let's start with the s equal at 0. It's the sum. We're gonna sum the math because we are going to make 3 calculations with the value 0, the value 1, and the value 2, like we did before, of with the probability of the murder be more than 2 per month. So for I in range k more 1, because if I just say key like 2, and the number 2 won't be included, so I need to pass one more s. Let's create the math of the Euler up to minutes average. Here I'm creating the Poisson distribution equation, okay, the formula. Let's multiply the average to the power of the I. There is the values, we're gonna pass the 0, the 1, and the 2, divided the math factorial of the I, the math is divided in the final, so I need to isolate this equation. And here we pass the x, not the key, and we return the equation, the 1 minus the sum. It started with the 0 and passing the 4, so in the case of the murder be more than 2 per month, it's gonna to pass 3 equations, the I like the 0, the 1 and the 2, and it's gonna be the sum, and it's 1 minus the sum. It's gonna represent the 87% like we just saw on the calculus. So in the Python I can use the input and you make the number of the event you would like to call. So let's create the average float input, and let's call it what's the average event you will pass, and the x int or the float input, what's the probability you want to calculate. In that case, it's the probability of the p, the x more than the k. I mean, the event it's more than what you would like to. In that case, it's the probability of the more than 2 murders per month. Okay. Let's call it the result and the average and the x. Now we print it. Print the probability to occur more than, let's pass the x. In this case, it's what we gonna to insert. Then 2 times the murders is, let's call it the result, multiplying by the 100 to convert it the percent, and use just 2 numbers of the dot and call the percent. Let's see if it's gonna work. Geolocation. Nah. It doesn't matter. 5 murders, it's the average in the country, and I would like the probability to calculate of the more than 2 murders in the location per month, and it's a error. I can't pass the float. Oh, of course, can't pass the float. It must be int. It's because the range it didn't support the float. Let's call it again 5, 2 murders. There is it. The probability to occur more than 2 times of murders, it's 87%. 5.53. And let's say 38%, and you can work on it and do whatever you want. Okay, that's the math of the Poisson distribution. I hope you have enjoyed. Subscribe for more videos, and if you like it, thumbs up. That's all for now.